Hello, I'm Peter Lum with Enphase's Learning and Development Team. Thanks for joining us for a brief discussion regarding the benefits of ungrounded PV power systems. Generally speaking, grounded photovoltaic or PV systems have two distinct grounding requirements. The current carrying circuit needs to be grounded with a grounding electrode conductor or GEC. These could include the negative or positive of a DC array, the neutral of a single-phase AC system, or even the neutral of a bipolar DC system. Also, the non-current carrying components of the equipment, such as the module frames, racking, and other metal enclosures, require an equipment grounding conductor, or EGC. However, the National Electrical Code does provide guidance for implementing ungrounded PV arrays, which carry additional safety benefits. Article 690.35 of the NEC covers ungrounded PV power systems, and Article 690.43 describe equipment grounding requirements. Additionally, Article 250 gives additional details on grounding and bonding requirements for general electrical, but relevant to PV power systems. These NEC requirements were developed to bring the U.S. PV industry in line with the rest of the world by adopting some of the European techniques and experiences for installing ungrounded systems, including overcurrent protection and disconnects on all circuit conductors, ground fault protection on all systems, jacketed or sheathed multi-conductor cables or raceways, additional warning labels, and inverters listed specifically for use in ungrounded arrays. Previously, in order to satisfy NEC requirements, microinverter systems were installed with both a GEC to ground the DC power system of the microinverter and a separate EGC to ground the metal case of the microinverter. For previous generations of Enphase microinverters, a DC GEC was still required because the input DC circuit was grounded through the ground fault detection and interrupt circuit to the microinverter case, which was the termination point of the DC circuit. Now all Enphase microinverters manufactured for use in North America feature integrated ground. By isolating the DC circuit, solar installers can build ungrounded photovoltaic arrays in accordance with NEC 690.35. Enphase microinverters with integrated ground can detect ground faults on either the DC positive or negative conductor of the PV module. Also new to these microinverters is the insulation monitor, or IM, which measures the insulation resistance of the DC circuit. These features offer greater safety than previously possible and allow for the removal of the separate GEC required for previous generation microinverters. Looking at the two microinverter diagrams side by side, the difference is clear. Isolating the DC circuit makes all the difference and satisfies NEC requirements for ungrounded PV power systems. Because the DC circuit is isolated and insulated from ground, the Enphase microinverters with integrated ground do not require a grounding electrode conductor or GEC connected to each microinverter. And since the microinverter EGC is incorporated into the engaged cabling system, no additional grounding materials such as the continuous copper grounding wire or weave grounding washers are needed. You can learn more about the advantages of ungrounded PV power systems and get the specifics about Enphase microinverters with integrated ground by downloading our white paper and technical brief. Also, we encourage you to contact Enphase for professional development training. Either through a webinar, in our online training center, or in person, we think you'll agree that Enphase microinverters with integrated ground are a significant move forward in simplifying and streamlining the installation of PV systems.